Thank you very much for joining me. This is Jose Fuentes, today your presenter for this webinar about showing consistency between textual requirements and models as a key practice for a successful systems engineering practice. So I will start with a very brief introduction about the Reuse company, established in 1999, trying to put together systems engineering and software engineering. The company is still headquartered in Spain, in Madrid, with offices in the United States, also in Sweden, and a special delegation, a special partner in Japan. The topics that we cover from a commercial standpoint is the digitalization of the life cycle by connecting all your different tools in your tool ecosystem. So we can say that for all of you who already know us for a long time, perhaps you are used to hear us speaking about requirements quality, requirements authoring. Indeed, this is the topic for today, requirements consistency. However, I encourage you, if you don't know what has been our evolution during the last few years, I encourage you to visit our website to discover more about our modules for traceability, connectivity, traceability, and interoperability, right? But this is not a topic for today. The topic is, as I mentioned, how to get consistency between requirements and models. So, as you know, we like to embrace this CCC approach, CCC for correctness, consistency, and completeness. While we can think of correctness for individual requirements, we check the correctness level requirement by requirement. We can also speak about consistency and completeness, but mostly, especially consistency, has to do with sets of requirements, right? So this is our approach. Completeness has two phases, let's say. One is completeness for each individual requirement, and the other one is completeness for sets of requirements. This is going to be the topic for next webinar, by the way. So if you want to learn about these three aspects, correctness, consistency, and completeness, correctness, we presented a webinar some months ago. This is the recording. When you get the slides, you will find this link to this past webinar. Completeness will be the topic for next month webinar. So you can, the registration is already open, so just follow this link and you will have the possibility to enroll. Or if you watch this recorded webinar within a month or more, then the recording of this completeness will be also here. And consistency is the topic for today. So let's dive into this topic. So let me start with the INCOSE guide to writing requirements, describing consistency as characteristics for requirements and needs, right? So there are different aspects, as I mentioned, like do not conflict or overlap with other requirements in the same set. I was presenting a webinar last year, some few months ago. I was presenting a webinar about how to detect and avoid the overlap requirements. This is the link to this webinar. Another aspect about consistency has to do with the way you deal with measurement units and measurement systems and these kind of things. The way you deal with decimal numbers to use them in a consistent way, the decimal point or the decimal comma to be written in a consistent way. I also performed a very short webinar about how to deal with numbers in your textual requirements to guarantee consistency all along your specifications. We can also think of consistency in terms of the names you give to the different aspects you mention in your requirements. And one of my colleagues, Elias, he was presenting a very nice webinar some months ago about the concept of project data dictionary to guarantee consistency in the wording of your elements. And of course, not to mention, the last part is consistency in terms of the structure of your requirements. You must keep your requirements following always, as much as possible, homogeneous structure. And this is where the notion of patterns can to play, right? So this is just a potential example of what a requirements pattern could look like. This is coming from INCOSE, the very well-known catalog of patterns, and then there is a recording for this year's our implementation to the EAS catalog that I had the chance to present together with Alistair Mavin. I presented this with May, and it was a lovely webinar as well that you can check here, and of course you can visit Alistair Mavin's website where he explains pretty well this simplicity but power of this EAS approach. So all this has to do, of course, with consistency, but today's topic is more how to check or guarantee consistency with the architectural models, which is as it is already described in the INCOSE guide. So it has to do with consistency between textual requirements eventually managed in a requirements management system with models managed in an MBSE tool, including product break structures, functional break structures, state charts, functional allocation between the functions and the logical functions, the logical components, use cases, actors, physical models, blah, blah, you name it, right? So quite a lot of potential elements, architectural elements, where you must guarantee consistency between your textual requirements and all those elements. So, and this is not easy. As you can imagine, this is not easy, mainly because of the recursive nature of a system. So when we start developing a system of interest, it is far beyond the notion of a monolithic aspect. Normally, we try to adapt this notion of divide and conquer, and we keep dividing this system into smaller systems until the size of this system is enough as to make the decision make, buy, or reuse each one of those components. When we can ask ourselves and have a clear answer to this question is when we stop the decomposition. And for each one of those system of interest, we should be dealing with a different requirements documents, right? So if we start with a top level system of interest, we can consider the system of interest as a black box, so that we can write requirements for this system as a black box, as I said. But in parallel, on the right-hand side of the slide, we start with the architectural definition of the system of interest, where we define the system of interest as a logical component capable of performing a series of different functions, F1, F2, Fn, functions allocated of course, to the system of interest, but at the same time, functions that can be divided into sub-functions like F21 and F22, sub-functions that could be allocated eventually to different subsystems. So this is why this is the way we can tackle the composition of the system with this composition relationship here, and the decomposition of our functions in here with these arrows in blue, and the allocation between the functions and the components. Of course, other elements like state charts, contextual diagrams, a lot of different information, and we must guarantee that our requirements in requirements management tool are consistent with the information in a modeling tool. How can we put these two words together? In our approach, you know that everything connected to the notion of requirements quality authoring and requirements quality checking has to do with a central ontology. And this central ontology is managed by a tool that is called Knowledge Manager. In this Knowledge Manager, of course, you can proceed and come out with the control vocabulary in this terminology block. You can continue with connecting the elements from your domain-specific vocabulary or grouping those elements according to the nature of the different elements. So all this can be done with our tool Knowledge Manager. However, at the same time, you can go to the extensibility block of the tool so that you can ask the ontology to be merged always in real time with information you have in models like Cameo, Capella, Rhapsody, Enterprise Architect, MATLAB Simulink, and other physical modeling tools. So in the end, what you will get is that the information from these models will be merged in real time into the ontology. not only every single time that you open the tool Knowledge Manager, but also every single time where you open any of the tools in our tool ecosystem, like the authoring tool, like the RQA capability to assess the quality, in this case, the consistency of a document, etc., etc., etc. So every one of our tools connected to the ontology will be loading first the information from the models, so that it can be used for correctness, consistency, and completeness. But let's focus on consistency today. So the first point is that as soon as I pick one of my patterns to keep writing the requirement, you will notice that, for instance, if I have to provide content for the precondition, the context of this state-driven requirement, then I can do things like naming a component which is in a given mode. So while the aircraft is in taxi mode, whatever. So this is a precondition according to this pattern. So and then in here I have chosen that the component is the aircraft and the mode is taxi mode. Where is this information coming from? The idea is that this information should be coming from a model, Cameo, Capella, Enterprise, whatever model. Right, so that the tool, as you can see in this screenshot, and as I will present in the demo, the tool will show in front of you all the name of the components whenever you write your requirement. And when it comes to define the mode, the tool again will go to the model and will retrieve all the potential modes connected in state machines for this component that you have chosen in the first block here, so that you always guarantee consistency, either in the authoring stage or later on. Suppose that you are given a document and you want to check it, to assess the full document to guarantee consistency, you can do exactly the same. So you can check that, for instance, this is this requirement that the last block, the system response is describing a transition between one state into another state or mode, right? And of course, the tool can guarantee, even if the document was written without the help of our authoring tool, the tool can guarantee that there are two requirements in my specification whose information is not fully aligned or compliant with the information coming from them. But anyhow, I believe that the best is if we watch this with this video. So I hope you can see now the video is coming. Okay, come on. Okay, so this is my video where first I show the information. In this case, it is a tiny model with one system of interest called Temperature Warrior, composed by 4 different subsystems below, and 6 different functions allocated to the different components. Right. So the idea is how to make sure that when I write a requirement, even if I write the requirement in an external tool, not in Cameo, but for instance in DOORS, how to make sure that I am consistent with the model. So first, this is Knowledge Manager, as I was presenting in the slide, and this Knowledge Manager is connected to the model. So the information that I was presenting in the model in Cameo, now it is shown, as you can see, in the different diagrams, not as a diagram, but as a static information, but it is collected in real time. So sorry, when I said static, I mean it's not graphical. But this tree-like structure is representing exactly the same information as in the model. And this little icon is telling us that this information is coming from the knowledge interface. In this case, I have created only one knowledge interface. However, you can create as many knowledge interfaces as you wish. So this is the only one that I have. So considering that all this information is there, and also considering that I create a pattern, and in the pattern I involve elements like this function, the function is coming from the model. So I can move forward a little bit and go to my requirements management tool. In this case, it is IBM DOORS. and I want to write a new requirement using the authoring tool. So whenever you connect the authoring tool for the first time, the tool has to connect to the ontology, and in second term, connect to the model and retrieve and merge in real time the information of the model with information from the control gallery. So this is the same pattern that I was presenting before, so that whenever I decided to start typing my requirement, I will see like the information about what are the potential names of my components comes from the ontology, as well as the information for the function. So I can pick one particular name of a component. I don't have to type even. I just pick. Of course, if I need to type, then I can type. But normally, I just select. And here I find the list of all the potential functions, so that I can pick one of them. Right. The point is that in this, according to the way I have defined this pattern, I am not constraining. I am only constraining the semantics of the elements, but not the potential relationships. So I have chosen the control system shall display information. It seems that the structure of the pattern is met. However, there is a metric telling me that there is no such relationship in the model between control system and the function display information, right? So this is not part of the model. So so the structure is okay, but the semantics is not okay. I can now go back and replace this function to display information, and I will modify this and replace this by the name of another function that in this case it is connected, allocated to the control system. So as soon as I change the name of the function, configure round, then I see now that everything is green. The left side is green, meaning that the structure of this pattern is okay, and the right is also green, telling that, meaning that the semantics is also okay. Now in this second video, what I'm going to do is I will take one step forward, and I will not only guarantee that what I write is consistent with the structure, but also with the semantics, and all this in real time. So the tool will only show in front of me those elements that are connected to the previous element that I have already written. In this case, I have chosen the wrapped assistant for your web browser. So I have a requirements document in code BIMA, and I can pick a pattern and start writing my pattern. So it is not important. The first block is not important. It's more important the last block. So I keep typing while the temperature warrior is in validation mode. If the round is completed, then the temperature warrior then here I can choose the name of my components. So the control system now shall, and now the number of functions that I will see here are only 3. Why only 3 and not the full list of functions? Only 3 because there is a contextual constraint between this cluster in the pattern representing the functions and the cluster representing the component. If I now go and change the name of the component, now the hidden system, when I go to see how many, which are the functions for this hidden system, I will see that there is only one, which is increased temperature, because there is this linkage in the patterns, a slot between the functions that shall be shown and the components that I have chosen in the previous system, right? So this is a means of guaranteeing consistency between one and the other. And that's all for this short webinar. Now, if you have any question, please use the text box. Go to a webinar text box to write down your questions. While you write down your questions, I invite you to follow me in the next webinar in the series of this CCC approach where I will speak about completeness. Since completeness is a two-factor quality aspect, completeness for individual requirements and completeness for set of requirements, then that's why this webinar will be a 1 hour webinar on April the 17th, Wednesday in the afternoon, European afternoon, and Thursday morning for us in Spain, Thursday morning, 9 a.m. So I hope you can join me for more about the CCC approach. And now, Cecilia, I don't know if you have collected any questions.
Yes, we have a question here.
Oh, nice.
Can we have knowledge interfaces to various models, and how are conflicts managed?
Mm-hmm. Yeah, good question. Yes, as I said, you can create knowledge interface to several models. When you do so, or even when you create a knowledge interface to one single model, there could be conflicts because, as I mentioned, the ontology itself natively already contains elements, contains clusters. Those clusters could be logical components, logical functions, so these kind of clusters where you can already put information inside. So it could be that there could be conflicts in this, right? Conflicts like relationships in one model and the opposite relationship in the other model. So this kind of thing. Suppose a composition saying that A can be composed of B, and then in another model I say totally the opposite. So whenever there is a conflict between two models, all the knowledge interfaces are numbered, ordered, right? So they are loaded one by one after the other, following this order. So the idea is that the information that is already in the ontology, this is the first aspect. If a model includes one piece of inconsistency between this particular model and the information that is already loaded, then the information already existing in the ontology will remain, and the information from this from the model which is connected, this piece which makes the lack of consistency will not be loaded. The rest will be loaded. If there are more than one knowledge interfaces, then for the next it will be the same. So we go to the second knowledge interface, and if there is no lack of consistency, information will be loaded. But if there is a piece of inconsistency, this little piece will not be loaded. So always the information that is already there will prevail.
Okay, let's take another question. Yes, how can I navigate from the modeling tool to the requirements? A, using an element, and B, implemented by an element.
I don't know if I catch the question. Indeed, if you can please rephrase. I start providing you an answer, but I think I am not catching. If you can rephrase a little bit, please, in the meanwhile.
Yeah, okay. How can I navigate from the modeling tool to the requirements using an element?
Yeah, I mean, I understood what you said, but I don't catch the semantics behind, right? So the idea is that whenever you open our tool, at the same time, even if, as in the first video, we have started with doors and Cameo and these kind of things, right? But in the end, the ontology is the bridge between they both, right? So that is why we can write a requirement or in those and check in real time the consistency with the model, which is in another tool, right? It is because we do the bridge, right? In this case, the bridge is not, let's say, a physical bridge, so we don't keep traces or we don't keep whatever. Anyhow, of course, with the new tools that I was mentioning at the beginning of the webinar for traceability and interoperability, we can build these bridges. You can not only guarantee consistency, but you can decide to automatically establish a trace between the requirement and the model element, right? But this is not the topic of this webinar. I think we will be presenting these kind of ideas in one of our next webinars before summer this year. And by the way, if I didn't catch exactly what you meant, please rephrase your question or.
Okay, so that's all right now.
Okay, you can send me a private message if you need to clarify this aspect any further.
Okay, just a moment. Let's see. We have seen that the model elements are used in the requirements. This establishes a relationship between requirement to model. We have also seen traceability from requirements tool to model. Is it possible to navigate the opposite direction from modeling tool to requirement?
Yes,
I understood it will be a topic of next webinar.
Exactly. Well, not next webinar. Next webinar will be on completeness, but perhaps in June we can tackle this very interesting point about connecting the dots. Let's say, right? But the idea is yes, we can automatically connect in such a case. We can automatically connect the requirement to the model element, and all of our traces have a direction. There is a direction in the trace. However, the traces can be navigated in both directions, right? So you can go from the requirement to the model, or you can the other way around from the model to the requirement.
Okay, thank you.
Okay, thank you very much. And I hope there are plenty of other contents and webinars in our website. Don't hesitate to visit the website for more information, or just to drop me an email to have a one-to-one conversation and discuss your needs and the capabilities of our tools. Thank you very much. Please stay tuned. See you soon.